Hello everyone and welcome to this section of the NMRFAM assignment workshop. I'm Mehdi and in this section we are going to go over the automated peak picking of Spectra, or in short APES. So what is the position of peak picking in the overall picture? We are going to assume that we have already done the data acquisition and processing. We have made the project using NMRFAM Sparky. You have done the Spectra alignment and contour optimization, and now is the time for peak picking. And for that, we can use NMRFAM Sparky with the plugin APES. So what is APES? APES is an automated peak picking algorithm for protein NMR. It is based on local maxima. There are three versions of APES. There's a standalone graphical user interface. As you can see here, there's a standalone command line user interface, and also there is the NMRFAM Sparky plugin that we're going to use today. There are some things about this plugin. It is slower and you will have more noise, but the good thing is that you can use NMRFAM Sparky features at the same time, and that would help you with validation of this automation. In this lecture, we'll use APES for backbone experiments and use other tools to validate and refine automatically picked picks. This is the overall procedure for using APES. There are 4 general steps. First of all, you're going to open the project and load the sequence file. This is mostly easy. You can just use the 2-letter code SQ. Then we are going to run the automated peak picking, or APES. APES will find all the picks that it can for us. After that, we need to go through these 2 steps to delete the noise at some threshold that we come up with, and after that validate picks using the strip plot section of the Sparky, and delete everything that is not there, not an actual peak. So we are going to start by opening the project. First, run a Sparky, and the first thing that we need to do is to change the home for Sparky. So go to Utilities and change Sparky home. It's right here. So I went to NMRFAM, Utilities, and Change Home. Here it asks you for the address. We have the project on the desktop, so we go to the desktop. There is a folder called APES Projects. Click that, and that's it. Just click OK. So you're going to click OK when you are in APES Project. Sparky is going to ask you to restart the program. So click OK, close the program, and run a Sparky one more time. Now we are in that folder. So you can go to Files, and we're going to open a project. This is a project, not a file. So a project, open, and we have the project right here, apes.project. Just select that and click open, and we see that we have all the experiments right here. Next thing that we need to do, or we can do here, is that we can use the view list to see if there's actually any peaks already in this experiment, in this setup. So you can go to view and then go to view list, view and view list, and you can see all the experiment in this project here, and also you can see that there is no peak selected or find at all. After we run APES, we will run this again. We will run the view list command one more time, and you can see that there are going to be lots of peaks that APES finds. So we can close this at this point. And next, one more thing that is useful for us to do is that we can change the background for CBCA CONH, and that would help us later. So just click there, go to view and invert background color. This is an optional section, but it is recommended. That will help you later. You can always use the 2-letter codes. For example, the 2-letter code for this was CI, but I'm going to just show you how to run these from the menus in case you don't know the 2-letter codes by now. Next thing is that we want to load the sequence file, or in this case just to confirm that the sequence file is already loaded. So go to this menu, then utilities, and you can see molecule sequence. You can just also press the SQ command and that would open this window. Here the sequence is already loaded, but if it wasn't loaded at this time, you could just go to browse and select the sequence. The sequence is also in another folder, but for now we can just go with this default. So sequence is loaded, click OK, doesn't matter, it's already there, so we can click OK. Next part is to just run apes. So we can go to NMR farm, utilities, and apes. So it was in NMR farm, utilities, and apes. It asks you if you want to use the stored sequence file and say yes. So this is the main apes window. Here you can see that we have the number of residues. Here we can confirm this, and we need to also tell apes what experiments it should use. So start from here. We are going to use NHSQC, and then CC. Sorry, we don't have that now. We have CBCA, CONH. We have HN, CACB, and CHSQC, CCONH, HB, HACONH, HCCONH, and we can also use taxi if you want, doesn't matter that much. So also we need to change the tolerance here. We can use a value like 0.35. That would filter some of these things, and then just run apes. It asks you if you want to follow launching apes by running iPine. We're going to have another presentation for iPine, so for now just say cancel. Another day you can just run iPine right after apes. So cancel, and you can see that apes is running at this point. There is this status bar here that shows whether or not apes is running. I'm going to pause the video for now because this is going to take some time, and we'll resume when it's done. Okay, we are back, and you can see that apes has finished, and it's asking us to validate the result. So just click K, and you can also close this window. We don't need the apes window anymore. The first thing that we can do is to verify if apes has actually found any peaks. So go to view, and then go to the view list as we did the last time, and you can see all the experiments, and this time you can see that apes has found many peaks in each of these experiments. So the next step here is to go over these results and delete the very obvious noise. For that, we are going to go do one more thing. So start with NHSQC, and we want to make these peaks sizes just bigger. You can do it by just using Control and K. You can see, and with Control J you can make it smaller, and with Control K you can make it bigger. There is also a way to do it from the menu. You can go to the peak and then more, and after that you can go to ornament sizes here, and here you can change the peak size, or as I said, just use Control K. Now we can start removing the noise peaks. We are going to use the peak intensity as the primary indicator. We are going to sort them by data heights and remove the obvious noise peaks. For that, we are going to use the peak list. First of all, select NHSQC window so it is selected. Then go to peak and open peak list. Note that if this window is somewhere else, like here, if you move your mouse, it's going to select something else. So you can either bring this window close to this, or you can just click here and then use the two-letter LT. So we open the peak list here. The first thing that we need to do is to show the data height for these peaks. So go to Option, click on Option, select Data Height, and also sort by data height. So we want to see the data height and also sort everything by data height, and you can click OK. Now you can see the data height for each of these peaks. If you double click on any of them, it's going to move the selection to that peak. Here we go all the way down to this list. Go to the end of this list. So this is going to be our weakest peak. Double click on it, and it's going to show you something here. Let me make this a little bigger so we can see this. So this is obviously not a peak. At this point we are not moving any peak around. If it's not a peak, if it's not an obvious peak, just delete it. So you double click here, it is selected here, press the delete key on your keyboard, and it's gone. Let's test something else. Okay, seems like this one is not a peak either. Delete. Next one, not a peak. Next one, can also remove this. Next one, remove it. Next one, next one, next one, and here can do an actual, yeah, this doesn't seem right. Okay, we can delete this one too. You don't need to do this for every single of them. Just as soon as you see an actual peak, something that you can see that is actual peak, just stop here. We are going to do a better validation in the next section. Right now we are just going to delete the obvious peaks, obvious noises. So next part, we are done with NHSQC. We are going to move to CBCA C9H. So here, select this LT, or you can just go through the menus in the program, and we're going to do the exact same thing. So options, show data height, sort by data height, and OK. And you can see shows the biggest one all the way to the weakest peak. Okay, this is not something that we are interested in. Delete. Next one, delete. Yeah, this is not a peak. Delete. Delete. I'm going to delete this one too, and so on. Yeah, this is not a peak. Just follow this procedure. Okay, I'm going to stop around here. You could continue this, but it's not necessary at this point because we are going to actually check these things later. Another way of deleting these is to just go up until you see something and then just drag your mouse and delete everything below that point. But this is fine for now. So now let's move to HNCACB, and here there is a difference. So let's just open the peak list, and we have the peak list for this, and we need to go to option, show data, and also sort by data height. And there is a difference for HNCACB, and that is that HNCACB is phasing carbon alpha and beta differently. Carbon beta is going to be negative. So if we just sort by data height and remove the last one, that's going to be the strongest, the biggest carbon beta peak. So we're not going to do this. We are going to go to the middle, right where we see the change of sign, so around 0. And that is the part that we need to start from, deleting peaks from each side, so this side and this side. So let's start from here. This is not a peak. Delete. Next one. Not a peak, and so on. You can do the same thing, so go up this list until you see an actual peak. Let's see, we can go higher, higher. Okay, I'm going to stop here, and we want to delete every peak that is smaller than this value in the positive side. So you can either just select this and start dragging your mouse down, or just double click here, you have it selected here, and then you can go to extensions, selection, and select same sign, smaller peaks. And that's going to select all the peaks that you want. You need to then take your mouse to the window, and because this is selected right now, you can press delete on your keyboard, and that is deleted. Next, we need to do the same thing for the negative side. So that's not a peak, not a peak, and so on. Or you can just continue going over this until we see an actual peak. Just continue browsing this until you see something that you are sure is a peak. So, okay, I'm going to stop around here. Yeah, I'm going to stop around here. I want to just delete everything below this. So that would be all the peaks that have smaller data heights than this big. So this peak is selected, it's selected here, and we can do the same thing. Go to extensions, selection, and select same sign, smaller peaks. And that's going to select all of them. Move your mouse here, press delete, and it's going to delete all these things. So this was the part that we had to do for deleting the obvious noise. Now we are going to do the validation, and this is the part that we are going to examine every single of these things and see if there's something missing or not. So for data validation, we are going to use the strip plot. You can open it by going to extension, view, and strip plot, or just use the two-letter code SP, and it's going to open the strip plot for us. Next thing, we need to go to the show menu and select the first option, and here we are going to use CBCA CONH. Just click here, and HNCA CB, another click here, and OK. Next part, select NHSQC, and let's see, we want to select all the peaks here. So this is selected, you go to peak, select, and select all peaks, or you can just press the two-letter code PA. You can see all peaks are selected here. Now we can bring these all to the strip plot, and this is the button that is going to do that for us. So you can either press this button or type the two-letter code SK, and you can see that we have these strip pairs for these peaks. So you have two peaks here, two strips here. The first one is CBCA CONH, and the next one is HNCA CB. And each of them we are going to examine. It's a good idea if you use this button here. Just make this as small as possible. Yep. And also you can use this button to make them a little bigger, just a little, so we can just examine what's going on. Let me make this window smaller so you can go up and down. And we're going to start examining these strip plots and delete each of these pairs if everything is fine. So what is fine here? We need to make sure that there are two peaks, as you can see here, for CBCA CONH, and there are 4 peaks, as you can see here. So 2 and 2, so there were 2 here and 2 there. Can make it a little smaller. So 2 and 2 for HNCHCB. The only exception is for glycine. So let's just move on here. So let's see. These two are fine. So we don't need to do anything here. There is 2 peaks here and there are 4 peaks there. Let me make this a little bigger. 2 and 4. So click here, and then you can either use this button, or another better option is to just use the 2-letter code SD, because if you press this button, it's going to delete everything, and that's going to ruin the strip plot. So just use the 2-letter code SD and 2 times. So we remove that part, and we are going to do the same thing for the next. Okay, you can see that we have 2 peaks and 4 peaks here. So this one is fine too. Just click here, SD, another SD, and that is gone. Okay, now we get to problem areas. We have 2 peaks here, but we have 3 peaks here. But let's see, so if we zoom in here, so let's see, if we just zoom in, you can see that this is elongated and they are not matching. Yep, they are not matching. So this is not the same thing. So there is a shoulder peak here that is missing. So what we are going to do is that we are going to select this peak right here, and just you need to change your pointer mode to selection. Select this peak and use the 2-letter codes OC and OP to copy paste here from here to here. So select this OC on your keyboard, and then go here, OP, and it's paste here. So you can see that now we have 2 peaks. So what we did was that we went here, we selected this one, pressed OC, copy, and we went there, pressed OP, and we created a peak that was missing because it was a shoulder peak. And now if we go up and down, we can see that we have 2 peaks and 4 peaks. So this pair is fine. We're done here. We can just delete them by using either this button or the 2-letter code SD. SD, another SD, and it's done. Next one, let's see. We have 2 and we have 4. And we are going to only emphasize on the ones that are on the center line, right on the center line. So 2 here, 4 here, these pair is fine. SD to remove it, SD and SD. Next one, let's see. We have 2, we have 4. This is fine. Let's delete it. SD, SD. Next one, 2 and 4. No problem. We can delete these strips. We are not deleting the peaks. This is just deleting these strips because we have already examined them and found that there isn't any problem with these. So we can just delete these. So again, 2 and 4. Easy, just delete them. Okay, let's see. So we have 2 here and 3 peaks here. Is it the same situation as the last one? Let's see. Yeah, so they are not aligned. We're going to say that there is a peak here that was missed. So very easy, just select this one and copy paste here. Click here, OC on your keyboard, OC, click here, OP, and we added this peak right here. Zoom out, let's see, 2 peaks, 4 peaks. We are done here. Just delete these two. Delete and delete. Next part, we have 2 peaks here, we have 4 peaks here. There is no problem, you can just delete them. Delete and delete. Again, we have 2 peaks and 4 peaks. I'm using SD to delete them. Here you can see my 2-letter code that I'm typing here. And we get to this part. Let's see. So we have 2 here and we have 3 here. So it's the same situation, yeah? So let's see. These two are matching. This one is not here. We can just select OC, copy, going here, OP, paste. And now we have 2 peaks here and 4 peaks here. So we can delete these strips. Delete, delete. Okay, next one, 2 and 4. There is no problem, just delete them. SD and SD. Okay. Now we have 2 peaks here and 3 peaks here. We are going to only care about the center line. So right at the center line, there are 2 peaks and 4 peaks. So it seems like there is a mismatch here. If we go here, yeah, they are not aligned. So just click here, select it, OC, and if you go here, OP, I'm typing here, and you can see it. We paste that one here too. And now we have 2 and 4, so we can remove this one and this one. Okay, this is an exception that we haven't seen before. So we have 1 peak here and we have 3 peaks here. So this means that this is going to be another peak that was missing. Yeah, here. So we can add this missing peak here. To add the peak, you need to change your pointer mode to find add peak, or just press F8. So change your mouse pointer mode to find add, and find where is the center line here. Yeah, around here, and just 1 click. So you added this extra peak here. You can go back to select. We have that, and now we can just copy paste it over here. OC, OP, and we have the same thing here. And 2 peaks, 4 peaks, we can delete them. And we are going to do the same thing for all of these peaks. There isn't anything strange anymore, so we can just continue the same thing, same procedure for all these things. We need 2 peaks here, 4 peaks here. If it's missing, we are going to add it or just copy from the other one. So we are going to do the same thing for all these peaks. We can do the same procedure for sidechain validation. Here, this would be our goal, and I also put the setting that we want to see here. So we want to check 3 of these strips and see if something like this happened or not, and just delete them one by one and go through. And everything is the same as backbones. Can do the same thing for sidechain validation for hydrogen. We're going to use these 2 experiments and the same situation. So either 1 or 3 peaks for HBCaCONH and 1 or more peaks for HCCONH. And everything else is same for backbone as backbones. I put some useful tips for you. So there were case number 1 where you could just use OC and OP to copy paste the peaks, or there was a shoulder peak that you can just create. And don't be fooled by signals in other planes, and you can use the comma and dot for checking this. And here are the areas that you are mostly going to see. So we are going to do the same thing for all these peaks. We can do the same procedure for sidechain validation. Here, this would be our goal, and I also put the setting that we want to see here. So we want to check 3 of these strips and see if something like this happened or not, and just delete them one by one and go through. And everything is the same as backbones. Can do the same thing for sidechain validation for hydrogen. We're going to use these 2 experiments and the same situation. So either 1 or 3 peaks for HBCaCONH and 1 or more peaks for HCCONH. And everything else is same for backbone as backbones. I put some useful tips for you. So there were case number 1 where you could just use OC and OP to copy paste the peaks, or there was a shoulder peak that you can just create. And don't be fooled by signals in other planes, and you can use the comma and dot for checking this. And here are the areas that you are mostly going to see. And that was all. Thank you for listening to this section.